Hi, today we're covering section 8-3, factoring x squared plus bx plus c. So take something to take notes on, pause the video at any time to take your notes or go back and review some concepts, and complete the check it out problems on your worksheet after each of the examples. Our learning target today is I can factor quadratic trinomials of the form x squared plus bx equals c. So we have three terms, makes a trinomial, and the degree is 2, so it's quadratic. So our first way we're going to do it is by guess and check. In fact, remember our last section, we started with either binomial or trinomial and ended up in this form. In this lesson, we're taking this form and going back to, we're undoing what we did when we FOILed. So to get x squared, we'd have to have an x term here and an x term there. Now we're looking for two numbers that multiply to give us 36, but add together to give us 15. So let's look at the factors, possible factors we have for 36. 36, we can go 1 and 36. We can do 2 and 18. So continuing on with the factors, these are all factors that multiply to give us 36. Now we need to look for our middle term. These have to be these two factors, they have to sum to be 15. So sum of 1 plus 36 is 37, 2 and 18 is 20, 3 and 12, oh, right here we have 15. So it looks like our two factors are going to be 3 and 12. Given 36 is positive, these both have to be positive to get a positive sum, so we do plus 3 and plus 12. And there we have our factored trinomial. And we can check it by doing what we did in our last unit. X plus 3 times x plus 12. X times x is x squared. X times 12 is a 12x. 3 times x is 3x. And 3 times 12 is 36, which gets us back up to there. So this is our factored form. And that's just guess and check. Factors that multiply to give you c term. So you're looking for ones that multiply to give you c, and c is the last term here, that add together to give you b. So here are your two check it outs to do. List the factors of 24 and then check their sum. So this is just a quick summary to factor a quadratic trinomial in the form x squared plus bx plus c, find two factors of c whose sum is b. And so here they look for factors of 18 that sum to be 19 or sum to be 9. So in this case, when c is positive, factors have the same sign. When b is positive, the sign of b tells you whether the factors are positive or negative. When b is positive, the factors are positive. When b is negative, the factors are going to be negative. So here we have, in this case, c is positive, b is positive. So we're looking for factors of 5. We have 1 and 5. And that's all we have because it's a prime number. And this does sum does equal 6. We have two positive signs. So both our signs in our binomials are positive, and 1 and 5. Doesn't matter which binomial comes first. We can do x plus 5 times x plus 1. Our second one we're looking at, factors of 9, we have 9 and 1, or 3 and 3. And 3 plus 3 equals 6, so it's going to be the second one. To be x plus 3 times x plus 3, because again, both of our positive 9 and a positive 6, and so a positive 3 and positive 3 gives us a positive 6. In our last example, in this case we have a negative b and a positive 5, or positive 15. So we need factors of 15 that multiply to give you 5, but add together to give you negative 8. So they both have to be negative. So we have -1, -15, and -3, -5. Well, those will sum to give us a -8. So these factors, those are our factors for this one. So it'd be x minus 3 times x minus 5. Now it's your turn to factor. Again, when both are positive, they'll both be positive. Positive and negative makes them both negative. Here they'll both be positive. Here both be negative. Both are positive. And here b is negative, so they both have to be negative. Remember, negative times a negative times a negative is going to be a positive here. So now, this is going to be when c is negative. Our last term is negative. The factors have to have opposite signs. One's going to be positive, one's going to be negative. b will tell us which factor has to be positive or negative. And so let's look at some examples here. Here we want a factor, so we're looking for factors of -20. We have -1 and 20, or 1 and 20. We have -2 and 10, or +2 and -10. We have -4 and 5, or +4 and a -5. So now, which one of these they have to add together to give us a +1? Remember, there's an implied 1 here in front. So the sum, this one, -4 plus 5 equals +1. So right here, those are our two factors. So it's going to be x minus 4 times x plus 5 is going to be our factored form. It's going to give us x squared plus 5x minus 4x minus 20. We'll just simplify to that. Positive 1x in the middle. Our second one, we're looking for factors of -18. So we're going to have -1 and 18, or 1 and 18, -18, -2 and 9, or 2 and a -9, -3 and 6, or 3 and a -6. Now they have to sum to give us a -3. So adding these together, this one here, 3 plus a -6 equals a -3. So those are our factors here. So it's going to factor into x plus 3 times x minus 6. And that's going to be our factored form. This is all guess and check. Here are your 3 to look at. Good luck. And a polynomial and the factored form of a polynomial are equivalent expressions. So a polynomial and a factored form are equivalent expressions. One is just all put together, the other one is taken apart. The results are going to be the same. That's how you can check your work to make sure you factored it completely or accurately. So here you want to factor y squared plus 10y plus 21. You want to show that the original polynomial and the factored form have the same value for when n is 0, 1, 2, 3, or 4. So here we're looking for factors. First, let's start out. We know we have to have y and y here, both positive signs. So it'll be plus and plus. Now factors of 21. We have 1 and 21, 3 and 7. They're pretty much done there. They have to add together to give us 10. Well, 3 plus 7 equals 10. So those are our two factors. So there, we're done there. And so now we want to check the values when y is 0, 1, 2, 3, or 4. If it's written in a polynomial or as the factored form, we should have equivalent, we should have the same answer. So let's check. So yes, indeed, it does work. When we substitute in 0, 1, 2, 3, or 4 to either this form or factored form, we end up with the same equivalent answers there. So here's your check it out. Again, check those values both in the original polynomial and in factored form. You should have the same value. So summarize this. When we're factoring x squared plus bx plus c, in this case where there's implied 1 there in front, a is 1, use the distributive property to multiply two binomials. But we're undoing the binomial multiplication by factoring. So we're undoing everything we did. But you can check your work with that. So good luck bringing questions to class. Thanks.